Hello everyone, N2CUA here, Randy. What I was going to try to do for you here today, just a kind of a quick guide for working with decibels. Not going to get into the nitty-gritty of it. We'll do that on a subsequent video. This is more aimed towards, say for example, when you're taking your test and you need to understand decibels enough to do your test, like the general, for example, or even the technician. Or you're just doing some work around the shack, and say you've got a transmitter down here, and you've got coax going over to an antenna here, okay, and the coax has 3 dB of loss or attenuation, and your antenna, say, has 3 dB of gain. Just really quick, simple example. And your transmitter power is 100 watts. Okay, that type of a situation where you can just kind of, without having to sit down with a calculator and going through all this in your head and pulling your hair out and using logarithms and all that, there is an easier way to do it. For the most part, it's easier anyway. So, 2 things to know to start. One is, well, 3 things actually. One is decibels are either going to be a gain or a loss. So they're going to be like an amplifier gain, an antenna gain, for example, or loss in a coax, or an intentional loss through an attenuator, or maybe an unintentional loss through an amplifier that's not working correctly. Those are really the situations you would deal with there. And then the other 2 things you want to work with, plus or minus dropping your pen and banging the camera, is the concept that 3 dB, I better write this big enough so you can see it, 3 dB is equal to either 1/2 or 2 times. So, and this is all, by the way, this is all in reference to power, okay? Anything I'm going to do with voltages would be in a subsequent video, because then you do have to do some calculations, and I'm going to do a little work with that too, and see if I can come up with some kind of a quick guide on that too. But for now, this is strictly dealing with power, RF power, and in this case for the ham radio, 50 ohm load, 75 ohm load, somewhere in there, okay? So the only thing that makes it either 1/2 or 2 times is just whether or not it's a gain, or whether or not it's a loss, or an attenuation, okay? So obviously 1/2 would be a loss of power. So that, and then 10 dB would be the other one, which would either be 1/10 or 10 times less, or 10 times more, okay, or of an increase. And that's a D, not a B. I don't know why I did that. Alright, so the way you would, and then you can work numbers in between. And the whole idea is between the 3 and the 10, you can come up with any number in between. So if you're given I'll give you a scenario with each of these first to start with. So again, with the 3 dB one we already did, you have 100 watts, 3 dB loss would be 1/2, so that'd make it 50 watts. When it got to the antenna, and then 3 dB gain would be 2 times, so that would be back up to 100 watts. So basically, whatever you lost in this case in the coax, you made up for in the antenna. So the power being radiated from the antenna is the same as the power being transmitted by the transmitter or transceiver. So it kind of equals out. But what if it's not the same? So what if you have a transmitter or transceiver? We'll say transceiver is better. And you have 100 watts again. You got your coax. You go out. And you get your antenna. I got that symbol upside down probably, sorry about that. And say this has a 10 dB gain. We'll mix 2 of them together, and the coax has a 3 dB loss, which is not unusual. That's especially in the VHF world, that's somewhat common. This is probably a little higher over here on the antenna side, but a lot of coaxes 100 foot 3 dB, that's not too awfully unusual. So you have 100 watts here, 3 dB loss. Again, 3 loss is 1/2, because you always lose signal through a coax in order to gain it. So that means at the feed point of the antenna, now you have 50 watts there. Alright, and then the antenna gain is 10 dB, which is 10 times, so because it's a gain, not a loss, hopefully, right? So you're adding a 0 basically, because it's 10 times. So now that has an effective radiated power, or ERP actually, what that's called, of 500 watts. Okay, so I mean it's kind of easy to work 3 dB, 10 dB. But what if you have something that is not quite so simple? So let's do that. Say now you get the transceiver here again in your coax, and you've got I don't want to make this too complicated. We'll make that, just leave that 3 dB again, and go out to the antenna, and we'll use that line for the antenna. And say the antenna is 14 dB. Had to do some quick math in my head there. So here's the problem you're going to run into now trying to do the 3 or the 10 rules, because you can do the 3 dB loss. So again, if you're back at 100 watts, that's fine. 3 dB loss, 50 watts at the antenna, same as before, fine. 14 dB, well, it's not a rule. There's no factor of 3 there, there's no factor of 10 there. Oh my gosh, now what? So what you do is you go past the 14 and work your way back to it. So in other words, I mean, if this were 13 dB, I should have said that first probably, but if it were 13, you could apply 10 to it, which would be, let's just put it up here, if it were 13 dB, you'd apply 10, which would be 500, right? 10 dB, like we did up here. And then you apply the other 3 dB, which would be twice, so then it'd be 1,000 watts. Okay? But because this is a factor, you can factor in and accumulate the 10 and the 3 together to get that, it still works out. But you can't do that with 14. There's no combinations of 10s or 3s in any form that will really give you 14 as far as adding them up goes, like this 13 is 10 and 3. Okay, you can't do that with this. There's no 10 and 4. Or there's no, I mean, even if it were 12, it'd be 4 3s, at least you could do that, right? But you can't do that with this one. So what you do is you go past this. In other words, what you would do is take the 50 watts that you know you have here and apply 20 dB to it, okay, which is now 100 times the power, by the way. Just so you know, another shortcut I forgot to mention is when you're doing 10, 20, 30, that kind of thing with dBs, the 1 or the 2 or the 3 and the 10, 20 or 30 is actually the number of zeros you're adding to that number. So when it was 10, it went up to 500 watts because we added 1 0. Okay, when it's 20, now you're adding 2 zeros, so it's basically 5,000 watts. Okay, but what we're going to do, whoops, one more zero, 5,000 watts. And then we're going to go backwards from there because we don't have 20 dB again, we have 14. But the difference between 20 dB and 14 dB is 6. And 6 is a multiple of 3. So you're going backwards from 20, you're going to drop down 3 dB, which is what? Half. So from 5,000, you're going down to half, which is 2,500 watts. Okay? And then you go down 3 dB more, okay, which is half again, which is 1250. Okay, so you basically went 20, then down 3. Actually, going the other way in 3. I take that back. No, okay, that's a little confusing. Let's not do that. Let's just do it this way. Okay, you took the 6 dB and worked it into the 20, so that what's remaining is 6 is 4 is 14 dB. Okay, and that's what equals this 1250. Okay. Point being, you went over to the 20 and then subtracted 6, 3 at a time, because those are the numbers we get to work with here that make it easy, and that brings you down to the 14 dB, which is 1250. First time I saw this, it was a bit confusing, but if you work a few examples with it, you'll find it works out all right, and it's easy enough to work with. I mean, like I could give some other examples, like, let's see, 11 dB, how would you do that? 11, if you went to 20, because you can't do 10 and plus 1 because that's not the ones we got to work with. We only got 3 and 10 to work with. But you could go to 20, and if you subtracted that 1 from 20, to have 9, and 9 is 3 3s. So you could do the same thing, when you just have to subtract 1 more 3 dB. So you go from 20 dB down 3 dB more, then 3 dB more, then 3 dB more. That would give you your 11, whatever that came out to, which actually in this case would be, if you did 3 dB more, which would be 11 dB, would be half again, right? Because 3 dB is always half or twice. Half more would be 625 watts. So, okay. All right, I hope that made sense. I know that was kind of quick. But again, by using combinations of 3s and 10s, you can pretty much calculate out anything as far as decibels go without really having to sit down in front of a calculator and doing logarithms and everything. And again, the other thing I didn't mention till later, which is important, again, if it's 10 dB, you're basically adding a 0 to whatever the starting power is, and 20 dB, 2 zeros, 30 dB, okay, 3 zeros. It's just another trick. It's quick, it's fast. Alright. And that's really about it. If you have any questions, please comment, post them. Please be civil about that. I mean, I'm doing this of my own free will and time for everyone, and I enjoy doing it. Don't get me wrong, I do. But keep the comments and the questions nice, and I'll gladly answer them. And the next video I'll do on dB, I'm going to, still setting it up, do some calculations, but I'm going to use the Rigel function generator and the analyzer, spectrum analyzer, and change the voltage, and then take those changes in voltages and convert those to decibels so that you can see that done that way as well. And that's that. Hope you enjoyed it. And to see you next time.